Hello students, welcome to Sourav Sir's classes. Today we are going to speak on the topic of infinite series. Okay, I'm going to speak on this topic, infinite series. So what are infinite series? Series that continue till infinity. Okay, they are like power series. Alright, power series. So let's go on to the objectives. Objectives would be, first one is understanding the definition of a power series. That's the first objective of today's video. Okay, then we will be finding the radius and the interval of convergence of power series. Okay, then we will determine the endpoint convergence of a power series. Okay, and the last one, we will differentiate and integrate power series. All right, we may not be able to cover all these, this and this in one video, but we will definitely cover it part by part. Okay, so let us start with the first one, power series. Okay, so here is the definition of power series. What is power series? Let's say there is a function f of x that is equal to ex. Okay, can be represented exactly by an infinite series called a power series. So you know that the expansion of e to the power x, in smaller classes you have learned this, isn't it? Where it is 1 plus x divided by 1 factorial. So it's like this actually. E to the power x is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial. Okay, and if you continue, plus xn divided by n factorial. Since it is an infinite series, after that also it will continue on. Okay, so for each x, it can be shown that the infinite series on the right converges to e to the power x. So the infinite series on the right means the infinite series on the right is this infinite series will converge to e to the power x, will converge to this, will converge to e to the power x. Okay, now look at this, the definition of a power series. A power series is written in this format, where you will write it like this: an, the series, n starting from 0 to infinity, an x to the power n. Okay, so the first one you're going to get a0. How you're going to get a0? You know what to do. a0 x to the power 0, first one. Why? Because here also you have an n and here also you have an n, and n is starting from 0, plus a1 x to the power 1, that's 1. Just let me rub that 1 off. Okay, x to the power 1 plus a2 x to the power 2 plus a3 x to the power 3. Okay, plus dot plus an x to the power n plus dot, means it is continuing. Alright, so it is an infinite series, the power series that is given over here. Okay, so you can see exactly how it's coming and exactly how I have written here. Okay, next, this is a power series, and more generally an infinite series of the form that is given here. X minus c now is, instead of x you have subtracted a c also. So every time you will have to put the value of n. So first one you'll get a0, then you'll get a1 x minus c whole to the power 1, then a2 x minus c whole to the power 2, and so on. Okay, so this is called a power series centered at c, where c is a constant. Alright, Let's go on to a few more examples on power series. Okay, so example number 1, you can see how this is. The following series is centered at 0. Okay, this. Why does it say centered at 0? Because you see, when you're doing x to the power n is just x, it's not x minus c to the power n. Okay, so even if the c is there, it's actually x minus 0 to the power n. So this c is centered at 0, right? Next one, you can see where it is centered at. The next series is centered at -1. Okay, so the c is -1, and over here the series is centered at +1. How do you get -1 +1? Very simple. Over here, look, concentrate on this part. So what is it given? X plus 1, isn't it, whole to the power n. Okay, so if you take x plus 1 equal to 0, then x is equal to -1. So c is equal to -1. Then that's the reason why this got added, because it's always x minus c, right? So x minus c, that's how you will get x plus c, right? Next one, you have x minus 1 to the power n. So if you do x minus 1 equal to 0, then x is equal to 1. So c is equal to 1. So it's centered at, this is centered at c equal to 1. This is centered at c is equal to -1. And this one is centered at c is equal to 0. Clear? Okay. Very simple things. And now we will go on to the radius and the interval of convergence. So let's go on there. Radius and interval of convergence. What does it say? It says a power series in x can be viewed as a function of x. Okay, so f of x is given as n starting from 0 to infinity a n x minus c whole to the power n. Okay, where the domain of the function is the set of all x for which the power series converges. Of course, every power series converges at its center c. Okay, so you can see over here is given, yeah, c minus c. When you do, what happens? Get 0 0 0. Okay, so first one, how do you get this as a 1? Of course, this is how you have to do. A0 c minus c to the power 0. So anything to the, so keep it c minus c to the power 0. So a0 1, a0 into 1. Okay, c minus c, anything to the power 0, anything to the power 0 is 1. Then the other ones you will get 0, because it will become a1 c minus c to the power 1. So actually a1 into 0, so that is a 0. And you will continue on to a2, that is a2 c minus c to the power 2. So that is a2 into 0, that is 0. So every term is 0, and you are only left with the a0 term here. Okay, all right. Next, radius and interval of convergence. So you can see over, so c always lies in the domain of f. C always lies, this c, the c over here will always lie in the domain. Okay, domain set of f. Okay, now theorem 9.20 is a theorem that I'll tell you what the theorem is. It states that the domain of a power set can take 3 basic forms. What are the 3 basic forms? A single point, an interval centered at c, or the entire real number line. Okay, so look at the figure that has been shown over here. So over here you can see that point over here c is taken. So they are talking about a single point here, single point. Okay, over here we have an interval. Over here we have the whole number line, okay. All right, let's go on to the next one. Radius, this is the theorem that they were talking about, okay. So let's read this theorem. Convergence of power series. For a power series centered at C, precisely one of the following is true. Okay, what is it? The series converges only at C. There exists a real number R greater than 0 such that the series converges absolutely. Okay, absolutely convergent. Okay, how? X minus C mod is less than R. X minus C is mod is greater than R. Okay. Excuse me. Next, the third point is the series converges absolutely for all x. The number R is the radius of convergence, okay, of power series. If the series converges only at C, then the radius of convergence is equal to 0. If the series converges for all x, then the radius of convergence is equal to infinity. The set of all values of x for which the power series converges is the interval of convergence of the power series. Okay, very, very simple things, very nicely explained. Okay, and I hope you also will understand it very nicely, okay, because it's explained very nicely. Okay, so let's go on to an example. Finding the radius of convergence. How would you find the radius of convergence? They showed you an example how to find the radius of convergence. So look, example, it says find the radius of convergence for this type of a series. Okay, for x0, what do you obtain? N factorial 0 factorial x to the power 0. So that is basically 1, because 0 factorial is 1, everybody knows that. Okay, 0 factorial is equal to 1 and x to the power 0 is equal to 1. So the first one is 1 and the rest of them are all 0. Okay, you can see it's coming as 1. So for any fixed value of x such that mod x is greater than 0, un is equal to n factorial x to the power n. So now what you have to do, you have to do this limit n tends to infinity un plus 1 divided by un. So what is un plus 1? So that is limit n tends to infinity un plus 1 is n plus 1 factorial x to the power n plus 1. Whole thing divided by un is n factorial x to the power n. Correct? So if you solve from here, limit n tends to infinity, this is n plus 1, then n factorial, this is x to the power n plus 1 minus n, whole thing divided by n factorial. N factorial got cancelled out. So limit n tends to infinity n plus 1 x, n plus 1 x, it is just x is left. So they have written this as a mod x. You want a positive value. So now what happens? Of course you will do limit only for n tends to infinity. The x has now become a constant. So they have taken out the constant outside and put the limit n tends to infinity n plus 1, so which is equal to infinity. So you got it? Alright. Therefore, from here what does it say? Therefore, by ratio test, the series diverges for x greater than, for mod x greater than 0 and converges only at the center 0. Okay, it only converges at the center 0, right? Look at it, only converging at 0. When you put 0 here, 0 factorial x to the power 0, then only it's converging. Otherwise it's diverging. Okay, so if it is converging, and the center and the center is 0, then of course the radius of convergence also 0. So radius of convergence 0. Okay, very simple logic. So students, we have discussed a lot today. As of today, we had started from our objectives. Okay, then we began with how power series is, and I have explained it clearly how the expansion is happening. Then examples on power series, right? Then we moved on to the radius and interval of convergence. So you will have a power series with the radius of convergence, and the center C will be given, the center at which, okay, the convergence at the center C. Okay, then from here what we did, then the radius and interval of convergence can be a single point, can be an interval, and can be on the whole number line. Okay, then we found a radius of convergence by doing an example. Okay, how did we find it? Everything is done over here, you can easily check it out. And then we found that the radius of convergence is 0. So that's it for today. You keep taking as much help as possible from Sourav Sir's classes, because all the help that you need will be provided at Sourav Sir's classes. Thank you for watching.